Hello and welcome back guys, you have very warm welcome to our YouTube channel Desi Astro, in the very third episode of Basic Astronomy and Astrophysics series. In this video we will be discuss basic concepts involved in Kepler's laws of planetary motions. Basically, Kepler's laws of planetary motion describe the motion of planets in the solar system. The laws were first proposed by German astronomer Johannes Kepler in the early 17th century. Let's first dig into history, how they got data and discovered these laws of planetary motion. Tycho Brahe was a Danish astronomer who lived in the late 16th century. Tycho Brahe is known for his precise and accurate observations of the positions of the planets, which he made without the aid of a telescope. He collected a large amount of data on the motions of the planets over many years, which he shared with Johannes Kepler, a German astronomer and mathematician. Kepler used Tycho's data to help formulate his laws of planetary motion. Tycho's observations provided Kepler with accurate information about the positions of the planets, which he used to test his hypotheses about their orbits. Kepler discovered that the planets move in elliptical orbits around the Sun, rather than in perfect circles as had been believed previously. This was the first of Kepler's three laws of planetary motion, which are now known as Keplers Laws. Tycho's data was crucial in allowing Kepler to make this discovery and to develop his laws. Although Tycho died before Kepler could finish his work, his data were used as a foundation for Kepler's discovery, which were later confirmed by Galileo and Newton. Tycho Brahe is considered as a pioneer of observational astronomy, and his data were of great value for Kepler's discoveries. These laws describe the motion of planets around the Sun, and provided a foundation for the development of modern celestial mechanics and the study of the solar system. Kepler's laws of planetary motion, also known as Kepler's laws, are a set of three laws that describe the motion of planets around the Sun. These laws were first described by the German mathematician and astronomer Johannes Kepler in the early 17th century. These laws were a major step forward in the field of astronomy and were used by Kepler to accurately predict the positions of planets in the solar system. They were later refined by Isaac Newton and are now considered a fundamental part of the study of celestial mechanics. These laws are followings. The first law, also known as the law of elliptical orbits, states that the orbit of a planet around the Sun is an ellipse, with the Sun at one of the two foci of the ellipse. Each planet's orbit about the Sun is an ellipse. The Sun's center is always located at one focus of the orbital ellipse. The Sun is at one focus. The planet follows the ellipse in its orbit, meaning that the planet-to-Sun distance is constantly changing as the planet goes around its orbit. The second law, also known as the law of equal areas, states that a planet sweeps out equal areas in its orbit in equal amounts of time. The imaginary line joining a planet and the Sun sweeps equal areas of space during equal time intervals as the planet orbits. Basically, that planets do not move with constant speed along their orbits. Rather, their speed varies so that the line joining the centers of the Sun and the planet sweeps out equal parts of an area in equal times. The point of nearest approach of the planet to the Sun is termed perihelion. The point of greatest separation is aphelion. Hence by Kepler's second law, a planet is moving fastest when it is at perihelion and slowest at aphelion. The third law, also known as the law of periods, states that the square of the orbital period of a planet is proportional to the cube of the semi-major axis of its orbit. This relationship is known as Kepler's third law of planetary motion. The squares of the orbital periods of the planets are directly proportional to the cubes of the semi-major axes of their orbits. Kepler's third law implies that the period for a planet to orbit the Sun increases rapidly with the radius of its orbit. Thus we find that Mercury, the innermost planet, takes only 88 days to orbit the Sun. The Earth takes 365 days, while Saturn requires 10,759 days to do the same. Though Kepler hadn't known about gravitation when he came up with his three laws, they were instrumental in Isaac Newton deriving his theory of universal gravitation, which explains the unknown force behind Kepler's third law. Kepler and his theories were crucial in the better understanding of our solar system dynamics and as a springboard to newer theories that more accurately approximate our planetary orbits. Thank you for watching this video on the topic of planetary motions. If you have any questions or would like to learn more, please leave a comment below. And please don't forget to subscribe my channel Desi Astro. Thank you again. We will back soon with other exciting video on astronomy and astrophysics.